Hi everyone, welcome back. Today we're going to be taking a look at solving linear inequalities, and that includes compound inequalities, okay? So we have a little warm-up up here, and this just kind of gets you thinking about equations again. So 7x minus 4 equals 5x plus 2, okay? Much the same, we're solving equations, getting things on one side, subtract 5x over, 2x minus 4 equals 2. All right, we're going to go ahead and add the 4 over, plus 4, 2x equals 6, divide, x equals 3. Cool. Okay. Number 2, you'll notice we have 4 different quantities and there are variables. So we have fractions. 3/5, 3/4, 1/2, 2/5. Let's find a common denominator amongst 5, 4, 2, and 5. So our least common denominator, LCD, is going to be 20. Okay. So what I can do is multiply all 4 of these terms by 20. Now, you'll notice 20 times 3/5. 20 divided by 5 is 4. 4 times 3 is 12m. Minus 20 divided by 4 is 5. Times 3 is 15. 20 divided by 2 is 10. And 20 divided by 5 is 4. Times 2 is 8m. That simple little move right there eliminates our denominator and allows us to work with just a regular equation now, okay? Let's get everything on one side. Subtract 8m over. 4m minus 15 equals 10. Add 15 over. It's really bad, 15. 4m equals 25. Okay. And then if I divide by 4 on both sides, we'll get our answer of m equals 25 over 4. You're all good. Okay. Wonderful. Negative 16 is blank compared to negative 19. So which one's less than, greater than, or equal to? Negative 16 is greater than negative 19. Think about the number line. Negative 19 is further left on the number line. Then over here, a little bit of quick math. Negative 12 just gives you positive 12. Obviously, negative 12 is less than 12. Cool. Okay, that one can slip some people up, trip some people up, but we're good. So let's get into the meat of the lesson today. Solving inequality with a variable on one side. Okay, so when you are solving an inequality, the only main difference you're going to find is that instead of an equal sign, you're going to have a less than, greater than, less than or equal to, greater than or equal to sign. So basically just treat it like an equation. Okay, your only really concern is if you divide or multiply by negative, then we have to do something with their sign, which we'll talk about in a moment. So here's our inequality. 5x plus 7 is greater than negative 3. Let's solve it. Okay, subtract 7, subtract 7. 5x is greater than negative 10. Be careful with those negative signs. Notice how I'm dividing by a positive 5. X is greater than negative 2. Boom. We are done. That's it. All right. If they were to ask you to graph this, which you know the directions don't say so, but in case you ever have to, there's 0 on my number line. There's negative 2. Because it's greater than, it's an open circle there. Greater than is to the right of it. Set to go. Okay. Very nice. Solve an inequality with variables on both sides. We want to get them isolated, of course, everything on one side. It's probably good I show you guys this one way. 2x minus 2 less than or equal to 3x plus 1. So we got some options here. Now, I will say I'm going to subtract 3x over. I'm doing this for a reason. I want to show this to you. Negative x is minus 2 is less than or equal to 1. Let's add 2 to both sides. Negative x is less than or equal to 3. And then my last step here is I got to get rid of the negative. When you divide by a negative, what happens to our inequality sign? Well, it flips. So it goes from less than or equal to the greater than or equal to. We're set. Okay. And again, just to show you, x is greater than or equal to negative 3. Looks very similar to the other one. Because it's greater than or equal to, it's a filled-in circle. And everything to the right. Okay. Directions don't say that. I'm just showing it to you. Why not? Cool. Okay. Using a simple inequality, a basketball player's average point total A in the last 5 games is, it's really hard to see, I apologize, x plus 123 over 5, where x is her score in the 5th game. Describe the score as X that will give her an average of at least 30 points. Now, when it says at least, we want it to be greater than or equal to 30, okay? I mean, you can have 30, but you want it to be at least that. So this is the score of our fifth game. Well, again, I don't like working with fractions. I don't really feel whole working with them, but so I gotta get rid of this divide by 5. So we can multiply both sides by 5. Cancels out. X plus 123 is greater than or equal to 150. Okay. You can subtract 123 from both sides. X must be greater than or equal to 27. Now, describe the score as X that will give her an average of at least 30 points. Okay. Must have a score greater than or equal to 27 points. Okay, or however you want to write that. You could say at least 27 points, so on. That's a good way of saying it as well. Okay, so now we're getting into kind of newerish ones, I guess, depending on where you're coming from. Solving an and compound or an or compound, okay? So an and compound can be written a few different ways. You can see it written with the word and, but a lot of times you'll see it like so. So you've got -9 is less than 2x minus 3 is less than 7. What you do to one side, you do to all three sides, okay? So I'm trying to isolate the x in the middle. We have to get rid of this -3 just like we would any other inequality. I add 3 here, I add 3 there, I add 3 over here, okay? The thing that a lot of people fall in a trap of is they only do it to one side typically. We want to do it to all three. Over here, -9 plus 3 is -6, less than 2x, because this is going to cancel out. Very nice. Now I'm going to divide by 2 to get x by itself. It's a positive 2, so I don't have to worry about flipping anything. So -3 is less than x is less than 5. Very good. Now, again, it doesn't say graph here, but you're going to be asked to graph at some point. My inequality, or my number line rather, -3, +5. We're going to put 0 right here in the middle. I always like just having 0 as a reference point. Less than, 2 open circles. Please notice where x is. Okay, they're trying to show you it's in the middle. So I'm only shading in the middle because the only quantities that work for this value are between -3 and 5. So and is in the middle. Okay, and in the middle for the most part. All right, I'd say 95% of the time. So if and meets in the middle, what do you guys think an or would do? Well, please don't overthink it, but instead of going in the middle, they're going to go out. That's all. So here we go. 2x plus 3 is less than 5. Or 4x minus 7 is greater than 9. So we're going to solve each one separately, right? So -3, 2x is less than 2, divide by 2, x is less than 1, or, okay, I'm just bringing this down, add 7, 4x is greater than 16, divide by 4, x is greater than 4, okay? So it's one or the other. You're going to notice that when we graph this one, there's my 0 for reference point, there's my 1, there's my 4, less than 1, open circle, to the left, greater than 4, open circle, to the right, and there you go. You're all good, okay? So that solves all of our compound inequalities. So you guys keep up the good work. It's just Batman saying good job, all right? He just wants to give you guys a thumbs up, okay? Rock on, keep up the good work. As always, good luck. We're all counting on you.